So in this video, we're going to look at experimental probability. What is experimental probability and how is it different than what we've already looked at? Okay, so with experimental probability, it's in the name. It's when you perform a task or a trial and you record your outcome and you can make some probabilities based on your trial. Okay, so in a probability experiment, a trial is repeated many times and the outcome is recorded. The relative frequency of the outcome is called the experimental probability. So if you had, for example, a coin and you decided to flip it 10 times and record down your information, we could then work out the probability of getting a heads and a tails based on your experiment. Okay, so if we don't just work it out like normally, 50-50, what we expect to get, we would do an experiment. To work out the expected experimental probability, we do the frequency of the outcomes and we divide it by the total number of trials. So what this means is if you had 2 coins and you flipped it 10 times, if you got 7 heads and 3 tails, to work out the probability of heads, you would do 7 divided by 10 because that's 7 heads and you've done it 10 times. If you want to do tails, you would do 3 divided by 10. Okay, with experimental probability, the greater number of trials you do, the better the estimation. So if we flip the coin 10 times and we worked out the probability, experimental probability, then we decided to flip it 100 times, the 100 times would be more reliable than the 10 times. So the more the trials, the better the outcome. Okay. So what have we been doing normally? Why would we not do experimental probability all the time? Well, this comes on to theoretical probability. Okay, so when we do probability normally or in the past, we do it theoretically. Okay, so for example, if we had this spinner and Louis uses the red spinner for a game and he wants to work out the probability of getting a D. So if you look at the spinner, we have an A, B, 2 C's, 2 D's. So just like in past videos, well, I have 2 out of 6 because there's 6 different positions, which means a third. So the probability of getting a D is a third. This is called theoretical probability. We've done this without an experiment. Okay, Louis didn't spin the spinner so many times and we actually recorded how many Ds he got. We are just doing this theoretically. We are just predicting what we'd expect based on the spinner. Okay, when we do theoretical probability, I could say, okay, we expect it to be a third. So if Louis decides to spin the red spinner 600 times, estimate the number of times the spinner will land on D. So using the theoretical probability, because we'd expect it to land a third, I would just do a third multiplied by 600. So a third, when you multiply something by a third, you can just divide it by 3, but if you want to actually do it correctly, 600 becomes 600 over 1. So that becomes 1 times 600, 3 times 1, and your answer is 200. So we would expect the spinner to land on D 200 times out of the 600, theoretically. Without an experiment, theoretically, okay? But what if I asked to do an experiment? So let's go to rolling. Louise is going to roll a dice, a 6-sided dice, okay? And the information she records in this table, so she can get anything from 1 to 6, and she records the numbers she gets for each one. So we can see she got 1 the most, we can see she got 5 the least. So based on a theoretical probability, we have to work out the relative frequency. So we have to work out, based on the experiment, what is the probability of landing on each number, and we use the fraction on the side. So for each one, I need to do the frequency of the outcomes, which is here, divided by the total number of trials. So how many times did she roll the dice? So to work out the total number of trials, we're going to add all the frequency up. So if we add all them up, we get 200. So she rolled the dice 600 times. And now what we're going to do is we're going to work out each relative frequency. So the first one is 46, and we divide that by 200, and we get 0.23 as a decimal. How many times do we expect to get the 2? Well, she got it 36 times out of the 200, so we'd expect it to be 0.18. 3, it was 44 out of 200, and we expect that to be 0.22. The 4 is 42 over 200, and the relative frequency for that one is going to be 0.21. 5 and 6 are quite low, so she has 14 out of 200, and we get 0.07. And then the 6 is going to be 18 out of 200, which is going to be 0.09. So now that I have all my numbers, okay, just like with probability in previous questions, the relative frequency has to add up to 1. So that's how you can check if you've done it correctly. Even when you do an experiment, your relative frequency is based on the trial. When you add them all up, it should still equal 1, which it does. Okay, so based on Louise's experiment, after 200 times she rolled the dice and recorded it, we've worked out the probability of getting each number. You can see it's more likely to get a 1 than it is to get a 5. So now that we've done an experiment, okay, let's say she decides to roll the dice 400 times, but doesn't record it. How many times would we expect to land on a 3? So now, because she's done the experiment with 200, we can actually use the relative frequency. So based on her experiment, the probability of getting a 3 is 0.22. And if she rolls it 400 times, we just times 0.22 by 400. And we would expect Louise to land on a 3 88 times. Which makes sense, because if she's doubling the amount of time she rolls it, it's obviously going to be double what she had in the beginning. Okay? And just like we said at the beginning, the more trials she does and records, the better the relative frequency is going to be, the better the estimation. So as the numbers of the experiments increases, the experimental probability should get closer to the theoretical probability. Okay, so all these, the more trials Louise does and writes them down, they should actually get closer to 1 over 6, because that is the theoretical probability of getting each one, which would be 1.6 recurring. Okay, and the only one that's quite close to that is the 2. So that is experimental probability.